Hey guys, so I just wanted to talk about adding integers really quick. And I wanted to do it by looking at these different problems. So 4 plus -2, -4 plus -2, and -4 plus 2. Now we know 4 plus 2 is 6. We know how to do that. We've been doing those kind of problems for years and years and years. So I want to show you one method first called the chip method. And then we're going to look at how we would solve these without the chip method. So if I were to use the chip method, what I want to do is I actually want to go in and I want to represent each of these numbers with symbols instead of the number. So 4, it's a positive 4. So I'm going to draw 4 positive signs right below it. And then I've got my -2. So it's 2 negative units. So I want to draw 2 negative signs right below it. Now, when we think about numbers here, we have these things called zero pairs. And a zero pair is like this, a positive and a negative. 1 positive and 1 negative. 1 minus 1 gives me 0. So they combine to make a 0. They're called a zero pair. What I want to look for is if I have any zero pairs and cancel those out. So this was a zero pair. That can get canceled out. I've got one more zero pair here. It can also get canceled out. Now notice here, I have 2 positive numbers left over, which means my answer would be a positive 2. So now let's look at -4 plus -2. So -4, I can represent with 4 negatives. And similarly, -2, I can represent with 2 negatives. Now when I look here, nothing becomes a zero pair because all I have here are negative numbers, which means nothing is going to cancel out. So my answer would be -6. So notice here, when I add together negative numbers, it actually gets more negative, goes farther into the negatives. So now I can look at -4 plus 2. And again, I'm going to draw it the same way I drew these two. So -4 is going to be 4 negatives. And then plus 2, I've got 2 positives. Now here, just like here, I've got some zero pairs that I can create because I've got a negative and a positive. So there's 1 zero pair and a negative and a positive. So I've got 2 zero pairs that I can cancel out. And what I'm left with is my answer. So my answer for this one would be -2. Now, when we're looking at this, the chip method is great for solving these problems when the digits are fairly small like this. I have 4 and I have 2. But when I start thinking about things like 50 and 60 and hundreds and stuff like that, using the chip method becomes very challenging because it takes up a lot of space, but it's also really easy to make a mistake. So I want to look at our answers here, okay? So when the signs are the same, so if I were to, I'm going to also add on here really quick below, I'm going to add 4 plus 2. So that'd be 4 positives and 2 positives, which gives me a positive 6. So I'm going to give you a couple of rules here. When the signs are the same, like with our 2 negatives or our 2 positives, when the signs are the same, add the digits and the answer has the same sign. So these were both positive, so my answer was positive. These were both negative, so my answer was negative. Where it works out a little bit differently, now let's notice here I have 4 plus -2, and I have -4 plus 2. And both of those really, I was canceling things out. So it was like I was doing some subtraction there, which is exactly what happens. So make this look as unterrible as possible. When the signs are different, you want to subtract the absolute value of the numbers. And then the answer has the sign of the larger absolute value. So let me explain what I mean by that. So 4 plus -2. 4 minus 2 gives me 2, right? Then notice here my answer was positive. The absolute value of 4 is 4, and the absolute value of -2 is 2. But 4 is bigger than 2, so I know because 4 is bigger than 2, my answer has to be positive. Over here, again, 4 minus 2 is 2. And now my 4 is negative. It's going to take whatever the sign is of the larger absolute value. Now, because I just want to do one more practice showing that, we're going to do that with some bigger numbers here. So let's say I've got 12 plus -22. So absolutely, I can solve this using the integer chips. It's just going to take a lot more space, and there's a much greater chance for me to make an error when I'm solving it. So the first thing I notice is that my signs are different. So really what I want to do is I want to subtract the absolute values, and I'm going to abbreviate absolute value here. So really it's 12 and 22. So 22 minus 12 gives me 10. And then I want to see the sign, whatever the bigger one is. Which is negative. So my answer is -10.